All right, this is Algebra 3 review for the final. This is going to be hopefully about 2 hours long in length. What we'll do is we'll stay here until questions have all been answered. Once the questions are up, we will continue on, and then we'll stop the podcast and go from there. A couple things that I want to make sure I address first are some things that are on the review that we might just need to talk over and talk through. So those that are in here can take out their review, and we can kind of talk through a couple of things on that. As you look through, if you could go to the page that has the graphs on them, the sine, cosine, tangent graphs, if you could go to that. It looks a lot like this one right here, right at the top, okay? Y'all see that right there? Go right to the top. Say that again. Yeah, it's the one that says non-calculator where you can graph them. So I want to make sure I address that. 18, 19, and 20, you do not have to actually graph sine, cosine, tangent, cosecant, secant, and cotangent. You don't have to graph those. What I will ask is this. I'll say the following. I could say, what is the period of this? What's the phase shift? What's the amplitude? What is the asymptotes on that graph? So that's really what we're looking at, are not necessarily graphing it, but just knowing how to find those components there, okay? And again, make sure also online and in this classroom, there's actually a hard copy of what the formula sheet will look like come exam time. So if you want one of those, feel free to take one of those and go from there, okay? I know on number 9 too, there's some question on what it's asking. If I gave you a word problem like that, I'll be very specific on what I'm asking for on that next page, okay? So we'll look into that number 9 a little bit later. Also, if you go to the last page, okay, so as you look at the very, very last page, I believe that there's one of them that will end up being like an angle side or side angle side. Just knowing how to do that, that's a big deal. So just kind of having an idea of how you could execute that. That's this last page here. Well, I guess it's second to last. It's this one right here. This one right here. The angle side angle, all that.
Wait, what page is that?
This one's page 3. I think it's the second to last one. I don't think it's the last one here. And I know a lot of people have come in, so welcome.
Yes.
We just started.
Page 3.
Yep, page 3. And then go to the very next page. It's the very, very back one. You'll notice that there's things like dot property, stuff like that. If you look at 36, from 36 to 42, okay? 36 to 42, it says like use dot product property and all that. But from 36 to 42, this page right here, the very last one, you can cross those out, okay? 36 to 42, cross them out. You do not have to turn them in on the review. They're not going to be on the review, and you do not have to turn them in, okay? They will not be on the exam. That's why we're throwing them out, okay? 36 to 42. Now, does anyone have questions on what I'm throwing out there? If you just came in a little bit late, you could watch it on the podcast. I'll keep that up. I'll put it up. But I want to make sure I address those few things, okay? Now, before I get into our problem areas from the exam, what I'd like to do is I'm going to turn it over to Eric's question because he's got just a few here. So we're going to go to the podcast, and then afterwards, after that, his questions, we're going to go over some areas that people struggled on last year. So when I gave the exam, what were some problems that people struggled on? And you'll notice that they're going to be very similar to maybe some of the areas that you may struggle on for this exam as well, all right? So, Eric, you want to just give me a number, and then we could go through that together, all right?
33 and 34 on the A4 page with the logs. It says solve the exponential equation, express the solution set in terms of natural logarithms.
Right on.
9 to the power of 5x equals 3.9. 34 is e to the power of x plus 7.
Perfect. Let's take a look at that. Numbers 33 and 34. And again, while you're looking for those, what we could do is kind of just put it kind of right above. The first one is 9 to the 5x equals 3.9. And I'm going to try to see if we can get this going here. My pen's not quite working. Man, now we've got a full house, right? Good stuff. See you, man. Sorry about this, y'all. Trying to.
Yeah. So are you doing that?
Yeah, what's that?
Are you about to do 34?
Yeah, I'm trying to. What I'm doing right now is I've gotten kind of booted off of mine. Hold on just a second. I will be right back trying to get this here.
When did we like it just me or so? Yeah,
Coach Jay, do you want a piece of gum?
Please come.
A picture of one.
Actually.
I did all the
All right, well, here's what we're going to do. Can you all see if I did it up on the board here? I know it's not ideal. For some reason, it's just not working. And that's okay. No worries whatsoever. We'll figure it out. So what we'll do is this. We'll make this, we'll shut this down. And what we'll do is we'll do it right behind me. Again, hopefully at home you can see that there. All right, sweet. And what we'll do is we'll actually turn off this projector. Do that. Turn this off. Awesome. All right, sorry about that. Okay, so a couple of questions that many people had, and I'll kind of move this here. So what I'll do is I'll write about right in here, and hopefully keep podcasts and see how this goes. On this one, it says, first of all, I'd like to back up where one says log base b of 81 equals 4. And what it asks is this: change it to exponential form. Now, the important thing to know is that, remember, the base of the log is always the base of our exponent. So when I shoot that over, when I shoot b over, what I have now is 81 equals b to the 4th. Now, is that an exponential form? It absolutely is. So we could actually stop right there, and there's our answer, okay? 81 equals b to the 4th. Now, that right there was 29. That wasn't Eric's question, but I did want to get that on the podcast there so that we could figure that out and go forward. Now, as I look at the podcast, we have some issues because right now it's backwards. That is great. So here's what I'm going to do. Could we do this? Could we take a timeout for just a second? And what we'll do, let me get something in the back. I'll hook it up and we'll be good to go. Okay? You absolutely can. Yeah, it's on my desk. Joyful.
Coach, we have the same password.
We have the same password, really? Yeah.
It was awesome.
My sister has my best friend has hers.
Yes, we are walking. Praise Jesus. All right. Apologize for those of you at home who have been wasting time listening to this. I apologize. We had some issues here. Excellent. Okay. So in talking about the log, what we have right now is on number 33, Eric has asked 9 to the 5x equals 3.9. Now, here's where the struggle comes, and here's where I'm going to need your help, okay? So I need someone with a calculator, because I know someone was borrowing it, which is no problem. What we need is someone to be able to help me out with the following, okay? Now, since I have 9 to the 5x equals 3.9, here's the issue. We've got to break that up using log form, okay? Yeah, A4. If you don't know, you kind of look at someone's next to you and they can help you out with that, okay? Now with this, what we try to do is try to get it out of exponential form, okay? We try to make it to log form. Now what we could do on this is actually apply the ln to both sides. Now, Cam, you're right. The 5x is going to do what now? Yep, because of the exponent rules, right? If there's an exponent within a log, this is a natural log, but the same rule applies. We could shoot it to the front to get 5x ln of 9 equals ln of 3.9. Well, because we can't, there is a way where, let's say we had 3 to the x equals 27, right? There is a way where in this, you could actually take 27 and make it 3 to the third. So 3 to the x power equals 3 to the third. Do they have like bases here? Yeah, we could cancel, right? To where x equals 3. You could do that, but the question is can you do that with 9 and 3.9? No. So because of that, I think it says in the directions, solve the exponential equation. And so when it says solve in that way, you want to make sure you take the ln of both sides to isolate that x. Does that make sense? Okay. So now what can I do to get x by itself? Perfect. Divide by 5 ln of 9. Now you could divide by ln of 9, then divide by 5. That's fine. But because this is all being multiplied, what we can do is when we divide, we could cancel out the 5 and ln 9 to where we'll say x equals ln of 3.9 divided by 5 ln of 9. And I think on the yes, I think on the exam I gave you, I want you to do it into decimal. But let's say you did go to decimal and it said, and it had this answer. Well, you could go back in your work and check that out and then go from there. So the only challenge with multiple choice is this, and this is the one thing that you got to be careful of. Remember that on a multiple choice, it makes you second guess yourself. Does that make sense? So you go through, and then all of a sudden you have two answers that look alike. So make sure, okay, don't look at the answers until you do the problem. Because once you do the problem, then go look at your answers. That's the best strategy, okay? Eric, you had one more, right? Number 34?
Yes.
All right, that's a good one too. E to the x plus 7 equals 2. Now, any suggestions what we could do on this one? Yeah, because what's the kryptonite of base E? Yeah, exactly. Ashley, you're right. If we take the ln of both sides, what happened is the ln and E can cancel, leaving me with x plus 7 equals ln of 2. Okay? X plus 7 equals ln of 2. Now, what could I do to get x by itself? Yep, subtract 7, subtract 7. X equals now ln of 2 minus 7. And what I do is this, so that you don't have that negative 7 in the ln of 2. Take ln of 2 first, then subtract whatever that answer is by 7, and you'll get x is equal to approximately, anybody get an answer there? Negative 6.3. And then on the other one, let's just go, I think on the other one I had approximately, is it 0.124?
Yeah.
Say that again, Kate. Just make sure on that, that's a big thing too, is just plugging it in right. I would take ln of 3.9, get that, then divide that by parentheses 5 ln of 9, close parenthesis. And so again, break that up because sometimes those calculator issues end up being the reason why you get it incorrect there. Okay? All right. All right, so Eric, I got 33 and 34. Do you have another one for me? We'll come back and we'll get it going. Okay? All right, at this time, could I go over with you the biggest problems from the exam last year?
Yes.
So these were, if it was the most missed problems, these are the ones that were the most missed and the ones we need to emphasize this year, okay? First thing is this. Every one of the problems is going to be multiple choice except the last 4. The last 4 are multiple choice, but let's say David got all 4 wrong, okay? If you were to get all 4 wrong, I could go and check his work to give him back credit on that. So just remember that going forward, all right? Do we have one where we do the x and y intercept on there? I thought there was, but I don't remember. No? All right, I'll throw one out there and, again, take this or leave it, okay? So right now we have, let's say we have y equals 3x plus 5. And I say find the x-intercept and the y-intercept. This is something good just to know for future sake, especially going to college. Anytime we solve for the x-intercept, plug 0 in for y. If I solve for the y-intercept, plug 0 in for x. Okay? Does that make sense? So plug 0 in for the opposite and then solve. So let's say this one's a good example of that. So if I say find what the x-intercept is, I plug 0 in for y. So 0 equals 3x plus 5. So this is for the x-intercept. What would I do to solve? What's up, Will? You're good, man. Yep, subtract 5, divide by 3, so x equals negative 5/3. Does that make sense? So I would put it as a point, negative 5/3 comma 0. And how would I solve for the opposite? To solve for what the y-intercept is, I'll plug in 0 for x. So it should look like this. Y equals 0 times 3 plus 5. So if I multiply that out, y would equal 5. And so my point would be 0, comma 5 for my y-intercept. So this is x-intercept, and this is y-intercept, okay? Now let me give you one that will probably be pretty close to what the exam will be like, all right? Let's back up. This one probably look like this. Y equals x plus 2 squared minus 5, and then I'll leave it as is, okay? So what would I do to solve for the y-intercept? 0 in for x. Good. Okay, so if I did that, I'd have 0 plus 2 squared and minus 5. So we get 2 squared minus 5 would equal what? Yeah, so y equals negative 1 would be what my point was. So with 0, negative 1 would be my y-intercept. Okay? So far, so good? Okay? David, you good? Awesome. If I solve for the x-intercept, I plug 0 in for y. So 0 equals x plus 2 squared minus 5. So what could I do to solve for this one? Okay, so what do I need to do first? Okay, let's add 5 first, right? So we then can get this whatever squared on by itself. So we have 5 equals x plus 2 squared. So what could I do here? Square root. Good, Ryan. So I have the square root of 5 equals x plus 2. Now if I square root a squared, what happens to the other side? Plus or minus, right? Remember that? Square root is squared. The other side is plus or minus. So what do I do with this 2 here? Subtract 2. Good. So it should be negative 2 plus or minus square root of 5. So if that's your x-intercept, really technically, it should look like that right there. Okay? All right. Again, most missed problem right here. This was one of the most missed problems on the on the exam. Okay? All right. Do y'all have another one? Well, any other questions on this one before I go to
Yeah, are you getting two solutions for that? Are you getting the 0 and 1, or is it just all in that?
That's a great question. Remember before, the last one I did was a line, right? So what's the most it can cross on the x and y intercept? Just once, right? But remember with this picture's it's squared. So what picture would that be? If it's squared, what will that look like?
Oh, it's going to be a parabola.
A parabola, right? So it could only touch at one point, right? Or it could touch twice. 1, 2. And in this case, it does. So you just say -2 plus or minus the square root of 5, comma 0. And again, because it's multiple choice, you could see it a little bit differently. But again, I do the problem first, then check your answers on that.
Okay.
And then go from there. Okay? All right. Mackenzie, you good?
Can you go back over the left side?
Yeah.
0 equals,
This one?
yeah.
So you see how in x-intercept you plug 0 in for y, right?
Yeah.
So when I add 5 to both sides, what I'm doing then is saying 5 equals x plus 2 squared. I'm guessing you struggled right here.
Yeah.
Because then once I get the squared here, I want to get rid of it so I could square root both sides.
Oh.
So if I square root both sides to get rid of that square, now I'm left with x plus 2 on the right. But when I square root a squared on the right side, I get a plus and minus on the left. That's why it's plus or minus the square root of 5 equals x plus 2. Subtract 2, and that's why I get -2 plus or minus the square root of 5 as my answer. Does that make better sense? And again, this one is almost identical to what the exam will be on. Okay, so I'm not trying to trick you on this. Y'all are here, so that means you really care about, what you're trying to do here on this final exam. Again, just trying to go over some of those problems with you. Okay. All right. Can I keep going over this? Is this helpful? Ones that they struggled on last year? I hope so.
Did you square root the 5 equals root x plus 2 squared? Did you square root both of them, like the 5 and the x plus 2?
Correct, because I wanted to get rid of this squared, right? If I square root the right side, I got to do it to the left side too. And that's why that 5 has to be square rooted as
The
well.
reason that there's -2 on the left side is because you have to subtract from the right side.
Bingo. Yeah, because Matthew had a great question. Because this is x plus 2, we've got to subtract 2 to get it to that left side. Okay? Excellent. Good question.
Whenever you square root, like something squared, I guess, it always becomes like plus or minus.
Square root is squared, right?
Right.
You got to have plus or minus on that left side. Yep, exactly. Exactly.
Can you
All
do
right.
another one like this?
Yeah, we could. Absolutely. So let's say I had, let's do this. Y equals x minus 1 squared plus 2. Okay? So if I were to solve for the x-intercept, what should I do? Plug 0 in for? Y. Very good. And you're right, Cam. You'll end up subtracting 2. So I'll take this plus 2, subtract 2 on both sides, leaving me with -2 equals x minus 1 squared. Now watch this. Okay, you can, but it's easier if you just square root it. Does that make sense? You know what I mean? So watch this. This is a little bit different. Same process though. Square root this side. What do I do the other side? Square root. Now this is going to bring me to another problem that they struggled on last year in just a second. But as I do that, what will I have? Well, I'll have plus or minus the square root of -2 equals x minus 1. Now some of you are like, man, this is a problem. We'll talk
Plus and minus.
because when you square root a squared on the right, it's got to be plus or minus on the other side. Okay? So what could I do to get x by itself? Add 1, just like Monzi said earlier. So what I have now is 1 plus or minus the square root of -2. Okay? Exactly. Now, here's the problem. When you did that, you have now a negative square root in a square root. So it's not a real number. So you've got to put an I to the outside. Now, if there's an I on the outside, what you have now is you actually have no x-intercepts. You might say, well, why is that? Well, because if you did, then this would be a real solution. Since it's not a real solution, the graph would look something like this. It would go here. Does that cross the x-axis? No, so there's no solutions. We keep it as is, and so there's really no x-intercepts. Only when there's a square root of a negative number. Okay? Great question. Yes, Morgan?
So the I is when you have a square root of a negative number.
Correct. Yes. And actually, we're going to get into that in just a second. It's actually something else that everybody struggled with last year. So we'll get to that. Okay. Great question.
So that would be.
You would just say for x-intercepts, there's none. Now, for y-intercepts, is there one? Well, we could plug 0 in for x, right? So we'd have y equals 0 minus 1 squared plus 2. Yeah, negative 1 squared is 1. 1 plus 2 is 3. So if y equals 3, then you'd have 0, 3. That would be a y-intercept. There would be none for your x-intercept because of that negative in a square root. Okay? It's not a real solution. One other one that I really saw that we struggled on, and maybe I could actually find one. In fact, I think I remember having one, just so that we're going through some of the ones that are on here as well. Excellent. Let's go to number 21 on A3, okay? Looks like this. 21 on A3. By the way, the answer sheet's all posted online on the top of the introduction page. Feel free to get that and look at that as well. Has all the work on it, has everything on there, okay? So 21,
Isn't this a quiz room?
it will be, yes. Yes, it will be. I think I did it as 1.5. I came down because I know I did. Yeah, I came between there. All right. So on 21, again, the most missed problem, one of them. Again, I'm going through these together. Right now, this one was missed. This should not be missed. I'll just tell you, okay? This should not be a missed problem. We should definitely tear this one up. This one states that the square root of negative 36 times 4 minus the square root of negative 81, and it says solve. Now, I'm sure some of you would come to this problem and not really have an idea of what to do, but again, it's not a tough one. The important thing to remember is that the square root of a negative number always comes out as an I, just like Morgan said earlier. So this square root of negative 36 should be I square root of 36 times 4 minus I square root of 81.
Would it just be 6i?
Yes, if you can jump to that, go ahead. I just want to make sure I show that that negative comes out as an I. Now, if you can make the jump from here to this next step, take it and go with it. Because we know the square root of negative 36 would be 6i, and the other one would be 9i. Very good. Okay? Now, at this point, I need to make sure I distribute out. So 6i times 4 would be, good, 24i, and 6i times negative 9i would be negative 54i squared. Okay, this is another important thing. This is not on your, exactly. Phoenix is right. This is not on your formula sheet. Okay, you've got to know this. I squared is negative 1.
Can we write it on here?
On that, you'll get a different one on the day of the exam. But again, I squared equals negative 1. That shouldn't be too bad. Just remember that, and we should be okay. Okay, so if this is negative 1, then I have negative 54 times negative 1, which is 54. So I have 24i plus 54. Here's another thing too. Standard form is always the whole number first. So even though this is correct, technically it should be 54 plus 24i. I don't think I trick you on that on the exam. That'd be mean of me too.
Gonna be able to-
So he's saying.
Yes, that's what I'm saying.
You're not gonna put 24i plus 54 versus 54 plus 24.
I don't think I do that. If there is one, what I will say is, like, if I said this, if I said 2 minus square root of negative 81, put that in standard form, then you know that this would be 2 minus 9i and not negative 9i plus 2, right? So this would be correct over this. That's not, okay? Because remember, the whole number always comes first with the I following, okay? Another one that a lot of people struggled on as I look at this is the one up above where it says 4 plus 6i times 4 minus 6i. Now, I can't tell you how many times people struggle with this, okay? Here's what normally people do, and I'll tell you right now. They'll go 4 times 4, 6i times negative 6i, and then whatever their answer is, they do.
Oh, you gotta do it.
You've got to FOIL out, okay? People don't do it. I don't know why, but a lot of people miss because of that. So if you looked at this one, what you could do is do 4 times 4, obviously. Yeah, 16. 4 times negative 6i gets me Yep, negative 24i. 6i times 4 is what? Plus 24i. And 6i times negative 6i is?
36i squared.
Good, Ryan and Katie. Good. Now, is there anything that could cancel here? Yeah, now that just so happens because they're conjugates of each other. But those will cancel, leaving us with 16 minus 36i squared. Well, what's I squared turn into? Good. So what does that in right here turn into?
Plus the 36.
Good. So 16 plus 36 gets me 52. Good, Mackenzie. Very good. Okay. All right. Do y'all have any questions on that one at all? Okay.
For the one before that, 18, would you just distribute?
Say that one more time.
Would you just distribute for 18 for that?
Yes. Let me make sure 100%. Yeah, 18 you just distribute. That's it. As I start looking at some of these, there are some, I put something on here that I think I need to just make sure I emphasize. That first page is one that is kind of a big deal. So make sure you know how to do that first page. One that, like the very front. One that people really, for some reason, they really struggled on was one like number 4, okay? One like number 4 was one that people really struggled on. First page, okay?
Yeah, how do you divide?
Let's look at it. Now, if I ended up multiplying and division are very, like they're synonymous, right? They're the same thing. The only difference is, does anyone know what the difference is?
Flip the chart.
Yeah, good. You actually flip the right side. With dividing, multiplication, you just keep it the same, okay? Now with this one, first step, factor out completely. So on the top left, how could I factor that one out? Good, x minus 3. What about the bottom? Good, 12 times x minus 3. When I flip the right side, what do I get? Over, and we could factor that too. Yeah, 8 times x minus 3. Now, is there anyone in here that struggled with where I've gotten so far?
Can you just cancel?
Literally, if it's on top and bottom and it's the exact same. Now, if this was an x plus 3 and x minus 3, it's got to be the exact same. But if you have something that's identical, cancel it out. So 1 and 1, and I also got another one here. 1 and 1. Now, let's rewrite this just so we are here. So I have 96 over, what's 12 times 8? Good. So 96 over 96 gets me 1 would be my answer. Now, the only difference between multiplication is you just don't flip that right side, okay?
Is this the one where you have to show the zeros, like you say, like it does not equal to 3?
Correct. Now, I didn't put that on the review sheet. I don't know why. But x should not be equal to a couple of things, right? Anything that said equal to on the bottom after you flip, right? You have to wait till you flip. It can't be down there. So what can I not plug in for x here and here? Positive 3 and positive 3, so you only need to say it once. So x is not equal to 3, and my solution would just be 1. Okay? Yeah, 0 wouldn't be. Now, if I had this down here, if I had 8x down here, then it would be 0. That makes sense? But it's not, so you just say 3 for that. All right?
So wait, for number 3, what would you do once you get it all factored out and flipped and stuff? Is it's just like x minus 4 over 12 times 144 over 12? Would I just like start dividing?
Yeah, so could I just rewrite this real quick? Let me do that. Let me back up here. Katie's got a good question on 3. Remember when we end up doing this, we should have x minus 4 squared all over 12 multiplied when we flip by 144 times 12x minus 4, right? Okay, so we flipped it already. Since there is a 12 and a 12, that will get what? Let me do this. Let me backtrack because I think I got ahead of myself. I have I could cancel one x minus 4, not both of them, but just one of them. Okay? So what do I have left over? Well, I have an x minus 4 times 144 all over 144, right?
Yeah.
So what I could do is cancel those 144s, getting me just x minus 4 as my answer. Now, what is x not equal to? Just 4, right? Even though this canceled out, if you plugged it in, right, even though it's canceled out, if you put a 4 in, X could not be equal to 4 on that. Okay? All right. Another one people struggled on was one like number 6. Okay? Where you add and subtract. Now, here's the thing. The confusion comes when you multiply and divide. What you're trying to do is just try to simplify. Adding and subtracting is a different process. And that's where people get confused on. Okay? How many of you just have some trouble with that? Knowing the difference? Real quick question. Multiplying and dividing, are we good on that one? Okay.
You just flip the right side.
Dividing is the only time we flip the right side. Good. Yep, got to flip that right side every time. Now, with the first step with number 6 is the same as dividing and same as adding. Okay, so now I'll explain here. Well, actually, what you all could probably have figured out, what would be the first step in adding and subtracting? Bingo. Same thing, right? Same thing we just did with multiplying and dividing. Phoenix is right. We've got to factor first. So let's do this. Can't factor the top left, so let's keep it as is. What can I factor the bottom left to? Good. X plus 3 and x minus 1. And keep the top right the same. Can't factor that out. What about the bottom right? X minus 6 and x plus 3. Good. Before you start figuring all that stuff out, though, let's figure out what x cannot be equal to. Yeah, and that's the same 2, right? What can it not be equal to? Good. -3, +1, and +6. Those are the 3 that I cannot, I just can't put in for. Otherwise, it would be undefined. So now I ask the question, when I add and subtract, I don't cancel out on top and bottom. The only difference now is we get what's called a common denominator. Okay, try to get a common denominator. Now, what about the bottom left is missing out of the bottom right?
-6.
Good, x minus 6. Yeah, goody. So we're going to put it in, and I'm going to multiply the bottom by it, but I have to also multiply the top by it as well. What about the right side do I need to multiply top and bottom by? Good, x minus 1. And I know it's here and here. Now, with the common denominator, you do not have to multiply the bottom. All you have to do is just combine it, right? So let's say we have 1/3 plus 1/3, right? Okay, what would we get? What would be the answer here? 2/3. Did I do anything to the bottom? No, same thing here. We're going to leave x minus 6, x plus 3, and x minus 1 all underneath the whole equation, okay? All right, so we've got that common denominator now. Now, x minus 6 times x minus 6, we're going to try to multiply that out so we can simplify just the top. So I multiply x times x to get me x squared, x times -6 to get me -6x, and then I do the same thing with the second value. -6 times x is -6x, and -6 times -6 is +36. Now, did I go too quickly there? Are we good? Excellent. All right, look at the next one. 2x plus 5 times x minus 1, okay? If I multiply 2x times x, I've got 2x squared here. 2x times -1 is -2x. 5 times x is 5x, and I'll put it down below. And 5 times -1 is -5. Now, I know that sounds like a whole lot of mess. I get that. Here's the thing. If you know the common denominator, then can multiply it out. It is multiple choice where you can end up going through after you figure it out to see, hey, does this match up? And that will always, again, help you if you're willing to show work on that, all right? So if I were to combine it, here's what I got for my answer. 3x squared minus 9x plus 31 all over x minus 3, or x plus 3, I'm sorry, x minus 6 and x minus 1. And that right there is my answer. Again, where x cannot be equal to -3, 1, and 6. Okay?
Which answer will be on multiple choice? Like one of the zeros or that one?
I could ask for either. I could say, hey, state what values cannot be
Because in our class,
plugged
we
in.
didn't get that answer. We just got one of the zeros.
On what one again? I'm sorry?
One that we're doing.
We did it in class.
We did it in class. We didn't get.
We did this right here. We did the top one? Perfect. Okay, so I've gone over both. If I ask you one or the other, I probably won't ask both on that. I'll probably say, hey, what about this? What about this? And so just knowing how to determine both is good. Okay? Both were struggle problems on that. Excellent. All right. There's also another dividing one that people struggled on, and I wanted to get to it. Let's see here. What if I asked you to do the following? This probably, yeah, let's do this one. Coming back to the complex numbers here, what if I said 2 plus 3i all over 1 minus 3i? Or 1 minus square root of 2 all over 2 plus square root of 3. Both of these will be the same process, right? We've got to what we call rationalize. We got to get that square root or the I out of the bottom. So what could I do for this one?
Times 1 plus 3i.
Bingo. I think you were getting to it, Phoenix. I've got to multiply by 1 plus 3i. All right, multiply there. So what I do to the bottom, I have to do to the good. What would I do for this one, just so we're clear on that? Good. Multiply by 2 minus square root of 3. Now the same process holds true with the top and the bottom, okay? So again, same thing. I just want to make sure you knew how to do this one, although I'm going to probably take the left-hand side here, okay? Now look at the bottom. We're going to distribute 1 times 1, 1 times 3i, negative 3i times 1, and negative 3i times 3i. What's negative 3i times 3i? Negative 9i squared, which would be positive 9 because I squared is negative 1. Okay? So we should have 1 plus 3i, minus 3i, and plus 9. These should cancel, so what should the bottom be equal to? 10. Very good. So we'll put the bottom just like that. Now, when I rationalize, which I'm doing right now, what's the goal? Why do I have to do that? We don't like eyes on the bottom. It's like kissing your sister. Okay? It's awkward and weird, and it's all weird. I see Jalen smiling over there. He's just smiling. How did I get the eyes to cancel? Oh, yes, because that negative 9i squared, I squared is negative 1, right? So negative 9 times negative 1 would be positive 9, right? So 9 plus 1 would be 10. Now, at the top, 2 times 1 would be 2. 2 times 3i, I'm just foiling again, is 6i. 3i times 1 is 3i. And 3i times 3i would be 9i squared. Okay? So we're combining like terms. When I do that, what's I squared again? I squared is? Negative 1. It's a big, big deal. What's up, Wes? Wes has been here the whole time, man. He just walked in and just, boom, get it going. So 9 times negative 1 is negative 9. So what we have right now is 2 plus 6i plus 3i minus 9 all over 10. So when I simplify, what I have is negative 7 plus 9i all over 10. That right there would be my answer. Okay? All right. Now, anybody confused by that? You need me to go over that again? Any problems? Is there anyone that needs me to go over this right side, or do you understand how that's the same process? Everyone good?
My question on the top, I thought that it would just, you just do 2 times 2 is 4, and then 3 times 3 negative 3.
On the top right?
Yes.
Yeah, so right here, square root of 2 times square root of 3 is what? Square root of 6.
Right, but like you multiply and square root would go away.
Be careful. Now on the bottom, yes. Square root of 3 times square root of 3 is what?
3.
Square root of negative 9, right? Or negative square root of 9, which is what? 3. Yeah, exactly. Good. But I only do that when I multiply common square roots, not when it's different. If it's different, like for instance, negative square root of 2 times 2 is negative 2 square root of 2, right? So that's just know the difference between those two, right? Now also something over here that you'll need to be aware of. What if I had this as my answer? It's not, but let's just say it was. 2 plus 6i all over 8. What can I divide all 3 of these by?
2.
Good. So you have 1 plus 3i all over 4. Now, here's why I hate the multiple choice and why I wish that we had time. Unfortunately, with the grades that have to be put in, that's why we have to do it so quickly, because there's just not enough time for overturn. But let's say you get this answer right here. Now, this is not every problem, so understand that. Let's say you get this here, but you look at your multiple choice and the only answer, you don't see this one, you only see this one, okay? You forget to divide. Well, again, I can't give you back half credit on that because of the fact that it is multiple choice. You got me? So it works for you, but it also works against you. Those little steps to go a long way there, okay?
So how much do you think we'll get, like if we show work for every problem, can you only give us back credit on the last one, or can you give us back credit?
That's a great question. I think I'm still not sure. So I'm still not sure. I don't know the time frame. I think the turnover is about 2 days. So it's just because the exams are a little bit bigger, that's the problem. So I'm going to say show work for everything, and let's just see what happens, okay? And then we can go from there. That's what I would say do. So show work, show work, show work. I'll keep emphasizing that, okay? Yes. Oh, is it our main?
I don't know.
All right.
Hello?
You're Coach Johnson right now.
I'm Brandon Johnson.
This is really, really weird. Don't be sketch or anything. Did you see him? The way he walked out, he looked really sketch. They're gonna wonder what's up. You know?
I guess I like to buy drugs.
No. Wait, you can't say that on the podcast. We're on a podcast right now. Yes. Good night.
I didn't know that.
Good night. All right. That's okay. What we'll do is we have to order more. We can order more and go from there. Okay. I know other guys have gotten food already, and that's fine. Okay. All right. Let's look at the next one. The next one we really struggled on was this one right here. Okay. And I'll put it in as two different things. Okay. F of g of x or F composite G, okay? I think, is there one that looks like this? I'm glad I'm going through a couple of these because I think a couple of them were not necessarily on there, were there? That's okay. That's all right. With this one right here, what's going to happen is this. I'm going to say f of x equals 2x plus 1, and g of x equals x squared minus 1, okay? And what I'm going to do is I'm going to give it to you in two different ways. I'm going to give it to where it's f of g, so g is kind of in f, and I'll give it to you this way, f composite g. Now, in both of these instances, whatever's on the inside, so the one that's furthest to the right or the one that's on the inside is what is getting plugged in for the other one. That makes sense? So it should make sense here, like f of g of x, right, means g is being plugged in for f, meaning that this x squared minus 1 is literally going in for the x of the f there. Okay? So we're doing, both of them are the same thing. There's just two different ways of writing that. Okay? F composite g, or you could say f of g of x, means g is going to be plugged in for f. And I believe, I haven't looked at the test too in depth yet, but I believe I tell you that. Like I'm very specific on that. Okay? So what this looks like is 2 times, what goes in for x again?
X squared.
Good. Plus 1 on the outside. All right, so literally this goes in for f of x. All right, does this make sense here? So I'll multiply this out to get 2x squared minus 2 plus 1. So my answer would be what? 2x squared minus 1. And that actually would be my answer. Now, is that tough? Not too much, right? Not too much. Just to make sure, again, be sure to figure out, just make sure you understand that. Now, what if I did this? Same thing. What if I did that? At the end, right? So still plug in g for f. I did that. Now I need to plug in -4 in for x. So it should look like this. 2 times negative 4 squared minus 1. So what's negative 4 squared? 16 times 2 is 32. So 32 minus 1 gets me 31 is my answer. So when you say f of g of negative 4, I know that sounds really weird. We know that solution will be 31. Okay? Now let me backtrack. Y'all want to try one more here? See if we can figure this out? Okay, let's do this. Let me do the same thing. Everything's the same. The only difference now, let's change this around a little bit. Okay, let's say I did the problem and I said, all right, try this. G of f of negative 2. So what do I do first? F into g. You got to be sure you don't say that too quickly. All right? So 2x plus 1 you plug in, okay? And when you plug in, some of you are like, what? It's all right. It's all right. So what I do is plug 2x plus 1 in for x, square it, and then minus 1 on the outside. Okay? All right. Questions on how I set that up? All right. Does that make sense?
Where's the negative 2?
Okay, good. Well, we're done. Are we done right now? Well, we could simplify, right? But we don't have to. Did you sign off as me?
Yeah.
You know that's illegal, right?
You told me to.
Oh, that's, shh, don't, on the podcast. I have to say that because, you know, of all that. Hey, do this. Just put it on the back of my desk there. Thank you so much. Don't look sketch or anything right now.
For the rest of the year, I'm Brandon.
Oh, my goodness. No, please don't. All right, so when I plug negative 2 now, I'm going to plug negative 2 in for x. So this is what I've got. 2 times negative 2 plus 1, square it, minus 1 on the outside. So what's 2 times negative 2? Negative 4 plus 1 is? Negative 3, okay. Square negative 3, get? 9 minus 1 gets me 8. The big thing that's going to kill y'all if you end up missing this is I think if you're here, you're going to understand how to plug it in. You're going to forget to do PEMDAS, right? Inside the parentheses first, square it, then subtract 1. That's a big thing to remember, okay? But 8 would be my answer there. Questions on that?
So you just
All
take
the way?
the negative 2 and just dump it in for the x, where it being g, or the f.
Dump it in. That's right. Put it in for x.
Okay.
Yep. Put it in for this x. So plug f in for g, then put negative 2 in for x.
Okay.
Okay? All good? All right. Right on. Can we do one more and then we'll eat pizza? Is that cool? All right, then we'll take a little bit of a breather. All right, this next one. Oh, yeah, we need to go over that one too. I've actually got 2 more. I'll do this one and then I'll save the last one for later. This one was one that a lot of people struggled on. If you could go to the back under chapter 5 and 6. All right, chapter 5 and 6. And then someone remind me on that chapter 5 and 6, we'll look at 19 too. That's a good one as well. But let's look at number 5, okay? Number 5 says sine of 255.
Yeah.
Now let's quickly talk through this. Can I do the sine of 270? Oh, it's done. Wow. Knocked me off here. I think I'm still podcasting here. I think it's just a struggle up here.
Coach J is short.
Way to be original, David. Haven't heard that one before. I go to Shorter University. You're really funny. I got a scholarship for that, by the way. Thank you very much for being short, that is. Going there. I think I'm joking. It's coming up. I'm hoping. How about this is a good time right now? Let's do this. Let's connect. Let's do pizza right now. This is perfect timing. And then I've got 3 more I want to do, then I'll open it up for questions, okay? Sound good? All right. If you want some pizza, go back, get some for yourself. Let's limit it to 2 pieces right now, and then afterwards, feel free to get more. There should be cups on the right side, and I'm not sure if there's napkins on the other side, but if you just a couple bucks is fine. Like right now, if you brought like $6 and that's all you have, like please don't feel like you have to give that much. Just a couple bucks is perfect. You can put it in the money mug back there, and I'll circulate that. So thanks for coming. I'll podcast, all right? No, go ahead. Yeah. No, it is. Sorry for those that are on the podcast right now. If you want to skip the next couple minutes, about 10, 15 minutes, that'd be great. At this point, all I'm doing is just trying to get some things up for people, get some pizza in everybody. And so if that is you right now, feel free, get that done and go from there, okay? All right, thank you all.
I wouldn't, just because I'm stubborn. If anything, I'd be like, we're married, or you have like Facebook. I have been so make sure you're not. She really, I feel like this is the one that I've gotten to.
It's the same with Miss Allen, so good. Y'all can go ahead. Perfect. Oh, you know what? Let's do this. Can we pray real quick? Pray for the food blessing. We'll go. Lord, thank you so much for today. We ask for help with the exams, just for seniors. Thank you for just all they mean to me in school. Bless them, Father. Bless us with your name. Amen.
How do you know where do you want to put money?
If you want to just put it right in the money mug right there, I'll just recirculate that with pizza in the future or whatever.
It was by yourself, that's right.
Yes, I am.
Annie, did you say you need another review? Is that right?
I was just wondering if you had another copy, just because I would rewrite mine. I have mine with me.
I'm going to try to get another one here, okay?
Oh, thank you.
You're welcome.
I'm gonna be in the station. Eddie, I hate myself. Eddie, you have to be on Secret Sunday. I'm not even like, I feel like I mean, I want to. What is it? It's just not us every day. And like, we're just like talking about like school too.
I think we'll have enough if we don't put in words.
You have to go. I can be a lot of money. We always have to. She has.
What's that? I hate myself, but I might be able to see it at all. I hate it.
On this Sunday.
Okay,
Yes.
I'm not. I want to. Just make what you add his through.
Sarah Carter, you're lying.
Wait, hold on.
I'm just asking her.
She looks like one.
You know, Sarah Carter. I'm not about to ruin it. After that,
Are you guys talking about your company?
no.
No.
And she's so trying to do that. I'm just asking her, does she? What is life?
I'm not gonna do anything to you. Oh, yeah.
I'll ask her for this.
If it's a chase,
Thank you.
you know, like.
That was so good.
Oh. Riding a line, he goes.
So I didn't see him.
They're calling this little dog Monty.
Laura, that was such a yeah, I heard about that. That was like such a weird, like, cool thing.
That's a first.
There was so much watching. My friend and I were just standing back, like,
Excellent.
watching. Yeah, people were like, cool.
Found this line in
And people were crowd surfing.
I had a line and his name
That's
was
crazy.
Monty.
It was so weird.
I heard a dog.
I've been, you know, the video on my Snapchat, I was like, I'm not going out there. So it's like. And then.
I told the whole group that's something on. I don't remember this now.
My friend got a video.
I did, I had
All right, y'all, as we eat, I think I'm going to go over just a couple prompts, and I'm going to use the time wisely. And I also, I'm still continuing on the podcast, so right now people are hearing us eat. So those that are listening at home, thank you very much. We will go over a couple up over here. Again, feel free, eat some pizza, get some back there. No problem whatsoever. If you already had two and there's some left, feel free to do that, and we'll go from there. Thank you, Dave. All right, so let's go over where we left off. We left off, we had a couple problems that I wanted just to hit on and kind of go through related to some of the problem areas within our exam from last year, okay? So the ones that I really wanted to hit on are these two right here, sine of 255 and sine of 270, okay? Now on both of those, Cam, help me out now, because this is podcast, it is live, okay? Just help me out there. You can talk, just make sure it is down there. Sine of 270, can we solve for sine of 270? Yeah, why can we? Bingo, it's on the unit circle, okay? So that's pretty easy, right? I mean, we can solve for that. We remember that sine is related to what? Good, nice. And cosine's related with? X. If you forget that on the test, here's an easy way to do it. Which comes first in the alphabet, C or S? C, very good. Which comes first, X or Y? X. So that's how X and cosine relate together. Sine and Y relate together. All right? Something easy. Hopefully you'll remember that. Or if you want to remember my good friend Sine and cosix. Okay? I don't know. I just came up with that. That was really corny. I apologize. So when I end up finding the sine of 270, I know that the point would be about right here. Okay? So we know that that'd be 0, -1 would be the point. And so what would the sine of 270 be? -1. Now, a lot of people knew that. That was, again, what a lot of people got there, okay? A lot of people got that there. Just give me all the work. That's fine. So once I solve for sine of 255, this is where the struggle takes place. Because people realize, man, there's not a 255 on the unit circle. And you'd be exactly right. So it's in that instance where you have to take the sine of either a plus b or the sine of a minus b. And with a and b, you have to have two things that are on the unit circle that you could use. So what are two things that we can add or subtract together to get to 255? And again, you'll have a unit circle, so you'll have that. You can use that. I like it. Nicely done, Mackenzie. Good. So 225 plus 30 with using sine, we call that the sum and difference formulas. And again, you'll have these formulas there. But if you don't have it on the unit circle, you can add or subtract two things together to equal that. Now, from here, what I can do is I understand that at this point, I've got a formula that states that the sine of a plus b equals the sine of a cosine b plus cosine a sine b. Okay, so that's sine of a plus b. I want to make sure I'm right there. It's actually, I'm sorry. No, that's correct. Yeah, so the middle sign for the sine stays the same. So once I do this, what is a? What goes in for a? Good, Wes. Good. What about B? Nice. Good, Ryan. And A would be 225, and B would be 30. Good. So we're going to plug that in just like that. Now, the question now becomes, what is sine of 225? Anyone have a unit circle they could look at? What's the y of 225? Okay. Good. I'm going to put this right here. So this is the first one, negative root 2 over 2. What about the second one? What's cosine of 30? Nice. Yeah. Root 3 over 2. Everyone has pizza in their mouth. That's all right. What about cosine of 225? Negative root 2 over 2 again. And finally, my last one, what's sine of 30? That 1/2, I believe. Okay. So now let's multiply the top and bottom together. Negative square root of 2 times square root of 3 would equal what? A lot of people mess this one up. What do we get here? Yeah, negative root 6, right? A lot of people say 6 because they see 2 square roots. It's actually negative square root of 6 over 4 plus what would be the top here? It's hard to see, I know. Negative root 2 over 4. So since it's a common denominator, what I have now is I could say negative square root of 6 plus, minus square root of 2 all over 4, and that's how you would put it in as your answer. Okay? Questions on that? Does anyone have questions on it?
Wait, how do you want it? Final answer?
Yeah, final answer would be, so I could put it here, negative square root of 6 minus square root of 2 all over 4. That's what you'll see on the test. Since it's a common denominator, you could put it all underneath, all over top of 4 there. All right. Now again, I'm not saying that there's other ones that weren't missed, but this last one was the last in the category of the most missed problems on the test. Okay, so this is our last one. Have you seen anything that's like overly difficult? Not really, right? Now it's going to take maybe some work a little bit, but nothing too overpowering. So if you focus on these and you also work on the review, you should be A-okay from that, okay? All right, now let's look at the next one. The last one I want to look at is on the very last review. And on the last review, that's a good one right here. The last one on the review states this: find the magnitude. In fact, I'll even give it to you. I'll even give you almost the exact problem right here.
Wait, which page is it?
This page,
The last one?
it's not really one that I've chosen. I guess I could do number 29. Let me do number 29, and I'm just going to add one more component to it where people struggle. How about that? We'll do that. 29, let's do U is negative 10i minus 3j. This one's number 29. It's one of the last few pages. Should look like this, where it says U plus V. Solve for that. Did y'all find that number? I think it's page 3. It's the second to last page. All right. Now, on this one is, again, pretty simple with how I would solve. Any ideas of how I would approach this? Add them together, right? So I could literally take negative 10i minus 3j plus 2i plus 7j and just combine together. Now, when I did that, what would I get? Good, negative 8i plus 4j. Excellent. And if I were to add together, that's all I would do. Now, if I subtracted, what would be the difference there? Let's say I put u minus v. Bingo, good, Wes. That negative would distribute to whatever the v was. Okay, does that make sense? Like, if I did u minus v, I would do negative 10i minus 2i minus 7j, right? So it would distribute to both of those. All right? Now, I'm going to give you something. This is, again, the most missed problem, one of them, on the test. In fact, I think if I remember right, this was the most missed problem, what I'm about ready to share with you right here, okay? If I gave you this, same problem, but if I gave you that, what would I do with that u plus v now? Okay, plug in, and I would get this out, right? Okay, but what would this mean?
That's the absolute value.
No, be careful. It's not.
Zero.
It's two parallel lines, so what would it be? Magnitude, exactly right. I heard it all the way around. I just want to make sure we were good. Magnitude. So what we have is this. Once I simplify, this is what I have right here. Negative 8i plus 4j with two lines around it. What that means is that's magnitude. Now, if you remember, if I were to graph this, where would this be graphed?
To the left.
Left 8 and
Oh.
to the left, to the left. To the left. In the closet. Isn't that right? So if I go left 8 and then up 4, you have to have some fun on this thing. Got to. If I go left 8 and up 4 now, I'm at the right spot. And what I do to solve for my magnitude is I find C. Or you just think Pythagorean theorem. If you could jump to that conclusion without showing this work, that's okay. So what we have now, oh, you tell me, what would I do to set it up? Good. 4 squared plus negative 8 squared equals C squared. 4 squared gives me what? What does 8 squared, negative 8 squared give me? Good. 64 and 16 make what? 80, good. So I have 80 equals C squared. If I square root both sides, I have the square root of 80 equals C squared. So here's again where you're going to have some problems as far as possibly with that multiple choice. Because the square root of 80, I guarantee you will not be on there. What I probably will do is probably end up simplifying that radical. So what two numbers multiply to get me 80?
42.
Good, 40 and 2, nice, Matthew. What would be the next one? 22. 20 would be?
72.
And 2 and 5, right? Okay. So if all of these right here are my factors, what are two numbers that are alike that I can pull out?
2.
A 2, what else? A 2. So I could have two 2's on the outside. So what's on the?
4 square root of 5.
Nice. 4 root 5 would be my real answer.
Let's
For
add
C.
them on the outside. Or I guess, or do you multiply it?
Multiply them on the outside. Yeah, it just so happens 2 and 2 make 4, and 2 times 2 is 4 too. Again?
Can we go back to the distributing?
Yeah, up here,
Would
absolutely.
you just multiply after you distributed it?
Yeah, so let me backtrack, Katie. Katie, that's okay. It's all right. Let me backtrack here. I jumped the gun a little bit on that.
So you would distribute it, making like negative 3i minus 7j, and then would you just multiply the two things together since there's no addition or subtraction?
So that's you, right? Okay.
No, I'm at number 30 right now.
Hey, Gilman. All right, so right now, you know. On that one, Katie, while I'm trying to get this up, you understand that on that specific one, right?
I understand that.
Correct.
But I'm just asking like the next step. There's no addition or subtraction in between the parentheses. You just multiply it.
Yeah, so that negative would be distributed, right?
Yes, and then you multiply.
No, you're going to add. Because now you've got negative.
There's no addition.
Well, be careful.
You can't just do this.
Be careful, right? If I said multiplying, I would say UV. Does that make sense?
Yeah, but then you distribute.
Does that make sense? So let me give you an instance. If I could pull this up, I apologize.
I mean, I'll just try to remember that. It doesn't make sense. But it's okay.
Let me give you a for instance, because I think,
Can we just do number 30?
yeah, we sure can. Yeah.
Because that's you minus 7.
Oh, yeah. We could do number 30. That'd be a good one.
What? Did I do what? Do you have Mr. Paul's? Do I have Mr. Paul's?
It's always on Twitter.
Oh, phone number? No. Wait, maybe. I don't think I do.
There we go. All right. So Katie, on that one, number 30, u minus v, okay?
So you get 11i minus 2j minus 3i plus 7j. You distribute it.
Okay, 11 minus 2j. Minus, and v would be 3i plus 7j.
Yeah, and then you
Okay.
distribute it. I get that.
Perfect.
But distributed.
When I distribute that negative, okay, you're still subtracting. Does that make sense? So if, like I said, if I went back, let's say u was 3i and v was 8i, okay? All right, this is really the same type of problem. Does that make sense? You wouldn't distribute the negative and then multiply. Because if I was doing that, I'd say uv. Does that make sense? I know what you're saying. You're saying in that negative right there, there's no positive there. When I take that negative out, I do that so that I can add together.
So you just gotta print it.
Correct.
And then it will be just like number 20.
Perfect. So if you look at it this way, here's an easy way to do it, Katie. When you distribute the negative, drop the parentheses. So
Okay, hold on. So it's the same thing. We don't really have to distribute. We'll get the same answer.
we don't have to distribute the negative.
Well, like you do in your mind, you'll get the same answer.
If you can make sure, the big thing is not the 3i. People get that one.
3i from 11i, and that's what you would do.
Perfect. But then you also got to do the 7j too.
So that makes sense.
Does that make sense? Here's what I do to remind myself. I do this. I say 11i minus 2j minus 3i minus 7j. And I drop the parentheses all together. Because once I do that, right, once I get to this point, right up here, Katie, without the parentheses, and I drop it after I distribute, there's nothing in your mind that says, oh, I've got to distribute this out now. Again, does that make sense?
Yeah.
I'm sorry. It's just something we got to remember. All right. Sweet. All right. So with that being said, what I've done right now is I've gone over for basically the first half of the time, the problems I feel like would be the biggest struggle for us. Okay. And as we've gone through it, y'all have had such great questions. I appreciate such a huge group coming today. I know that, again, this is your day off. You don't have to do this, but I know that it's going to go a long way in preparing you for the exam. Okay. Is there, now at this time, what I'd like to do is just kind of open up the floor to questions that you have, off the review, questions that you're looking at, and that way we can go through them together, all right? Morgan?
Can you go over the triangle where you have to make like a little chart thing, like your angle side?
Absolutely. Yeah. Let's do it. Tim? Huh? I'll post this online. Okay? All right.
Are you doing a podcast?
I am.
Okay.
Still podcasting. Everything's on here. Number 22. Let's go over 22 together. On the second to last page, 22. Okay, second to last page, 22. In fact, let's do number 23. I think that one's a little bit better. More realistic on that. All right, angle B is 11 degrees. Number 23 on the very last page. B is 12.1 and A is 31.71. Okay, so first thing to do when I get this is let's make a triangle, okay? So we got angle B is 11 degrees. We know B is 12.1, so it's opposite of that side. A is 31. Little a is 31.71. And we have angle C and little c. Okay? So this is what I have right now. Now, question, how do I know there's possibly two triangles? Angle side, right? Now, remember that chart that I gave you? If you look at the formula sheet that I put on that table, that is going to be on there too, so you'll have that. Okay? You'll have that for the test. So if you remember angle side, we know there's two triangles. So Morgan, to answer your question, I know at that point that is the only time that I'm going to create my chart. If it's side angle side, if it's side, or anything of that nature, we cannot, we don't have to. We know it's only going to be one triangle there. Okay? All right. So the triangle that we're going to solve for is we're focused just on the angles right now. So what angle can I solve for? What angle can I solve for?
You
Angle
have-
A, right? That's
B
it.
is 11, so you solve for C, right?
Be careful. With angle C, I can't because I don't have either parts. Does that make sense?
You have B, so you just solve for A.
We could do B. We can do A, though, because we have one of them at least. Does that make sense?
You go ahead and put 11 in the chart.
Yeah, you can. Absolutely. So you could put 11 degrees here. What would be the second one? 11 because it's given, right? Good, Katie. So I'd say sine of 11 over 12.1 equals sine of A, big A, over 31.71. Now, if I cross multiply, divide, and all that, what I'll get is 31.71 sine of 11 equals 12.1 sine of big A. So I'll divide by 12.1, divide by 12.1. Okay, we'll pause for a second. Ryan, you got one?
It's not going to do anything.
Gotcha.
It's not going to do anything. When you put it in with the inverse sign, it's
Mhm.
going to end up with nothing. So it would be no triangle.
Okay, so what's 31.71 sine of 11 divided by 12.1? Did you do that?
Yeah, it's negative 2 point something, so the inverse would work.
Are you sure on that?
Yes.
Did someone else do that? Just to be clear? Yes. Okay, I think. Sure. Oh, brings up another point. Make sure on this you're in degrees. Okay, make sure you're in degree mode.
I am in degree.
Yours was right, actually.
It was.
Yeah. So just put it in one more time, Katie, and you'll be okay. All right?
So an angle side, it's always only 2 triangles.
It's not always. You're going to test to see, right? That's when we do our chart. Say that again.
Can't be 2 triangles on the other one, like side angles.
Correct. That only time is with side angle or angle side. All right. So now I've got angle B. We've got that down. We're good to go there. All right. Sure of it. Hold on just a sec. My technology's failing me right here.
So it would be 30.
Correct. So once I solve for that angle A, do we get 30 degrees? Is that what we got? It's frustrating. Say it again. It's our first one. 8 to 9:30. All right, so as I solve this, I know that right now I've got 30 degrees as my angle A. Okay, 30 degrees. That's my first angle. All right, help me out here. Okay, help me out. Make sure we keep it down. Y'all been great. Make sure for those that are podcasting at home, Maddie, have a good one. I know that for my first angle, that the second one and the first one are always added together to equal 180. So if one is angle A is 30 degrees, what would be the second one? 150. Very good. You 150.
So to figure out the box, you get to whatever number you put inside, you can subtract it by 180.
Correct.
Then you'll figure out the second.
Correct. Okay. So Phoenix, I always say there's 3 180s in here. Okay. 3 of them. All right. One is at the top here. Okay. The first one only the first one I solved for. Then the other 2 are these ones side to side. That makes sense because you have 2 different triangles. Make sense? Bob?
I still don't understand like how like 1 triangle or 2 triangles.
How do you know?
Yeah, I don't know.
We're about ready to go through that right now. All right? Sure. All right. So if you have one that's 30 and 11 degrees, right? 30 degrees and 11 degrees, I can solve for this. Let me backtrack for you, Rachel, so I can answer. Do you understand how I got 30 and 150?
Yeah.
30 was my original. 150 has to add equal to 180. Right here, this next part's where I test to see whether it's 1 or 2. Okay? So this first triangle will always be able to be equal to 180, right? So 30 plus 11, 41, subtracted from 180 is 139, I believe, okay? So 139 is angle C. Now look at the next one. This next one is where the rubber meets the road, okay? This is 150, this is 11. what would be my third angle? These add up to equal to 161, right? What did you say, Ian? 19 degrees is perfect. Now, if I only had one triangle, this 19 degrees would not be able to be there. Does that make sense?
Oh, so like all adds up equally.
Correct. So because it's 150 and 11 degrees, let's say if this one was like 170, right? 170 plus 11 is 181. That exceeds 180. I can't have a third angle. Therefore, I only have one triangle. Does that make sense? And when it's none, then at the beginning, it'll say error, right?
Okay.
And make sure, again, just like with Katie, she did it completely right. Just make sure your calculator's in degrees because you're putting in degrees. All right?
Okay, but for 22, there actually is.
Correct. Number 22 is no triangle. All right? Now, again, how would I solve for side C on this triangle here? How many side C's would I have? 2, right? And I would use what? Law of sines, right? I could do sine of 11 over 12.1 equals sine of C over this C over here on this side. Okay, just do that twice. All righty. We're good, David?
So we can't have the decimal for the angles, but the sides.
Correct.
Do we not need to find little a and little b?
Well, you have little a and you have little b. The only one you need is
On the second triangle too.
you'll have to do 2 of them. That makes sense? So same thing here, sine of 11 over 12.1 equals sine of 139 over little c, or the second one, sine of 19 over little c. And that's it right there. All right.
How many triangles are there?
How many triangle ones? I want to say 2 or 3 out of 40. Now, some of them are going to be very quick. Some of these questions will be fast. Here's the thing. What I would do not spend too long on one. If you've got the opportunity and you don't know it, circle it, go.
How long
Because-
do you think
40 questions.
40 questions.
Mhm.
40 multiple choice.
40 multiple choice.
Multiple chess?
Chess.
Yeah, multiple chess.
Chess.
Yes, 40 multiple chess.
That's it.
That's it right there.
No, he's kidding.
Eight o'clock. I'm worried. My wife is coming. I'm worried.
Your wife is coming?
What's that? Yeah. Smart. All right.
Can you tell us what's not, like, why are there only 40 questions?
I told you those things beforehand. Oh, yes, I'm sorry. Any and the rest, I printed them off. They're in the printer. So, Annie, would you mind getting that real quick?
Thank you very much.
Good luck.
Okay, well.
You got it. You had it?
If I have any questions,
Yeah, we don't get
if I have any questions, guys, just email me.
Yes.
It's
No.
multiple choice.
No.
It's multiple choice.
All right.
What is this?
Hmm?
What is this? What's that?
One sec. Thank you very much.
Okay.
Okay, I'll see you guys.
I'm sorry about the other day.
Other than that, how that, the one that comes in is hard.
All right.
Tangent, do you do like the x over y or y over x to figure out what that is? Like so over y.
Good. All right. Now, I realize right now y'all have been very quiet for a long time. I know there's still some questions here. So if you're like, you know what, I just want to chill, no problem. Just make sure, again, we'll keep it down. Or if you want to just step out for a little while, that's no problem. You're not offending me, right? But I know I've got a few questions still out there. I know Phoenix, I said I was going to touch base on hers, and then I'm going to go to Katie's. And then afterwards, again, if you have more questions, let me know, okay? That's fine. Perfect, that's fine.
Hey, and then
Yes. You get
Is this on? I got it. Yeah, I got it great.
Did you?
I don't know why I got the grade.
Did you get it? Did you get the song? Okay, you can look on the left hand hand side if you want to.
Okay, because I'm
Or
still going
right
with
hand
what I
side.
got wrong, because I did
Perfect.
everything on the.
And if you did it, that's why I say check it.
Okay.
That makes sense?
Yeah.
So look on the right side real quick. Okay. All right. Now, can we continue? Those that need some help, we'll continue. And if not, if you're done, no problem whatsoever. Okay. So those at home, hopefully you're bypassing all the extra stuff and getting to the good stuff here. Now this one right here, again, toughest one I probably could give to you on this exam. Okay. As far as with the unit circle.
Should you make it into a degree?
That's what I would do. E's right. I would change it to a degree to where now it's cotangent of -11. What do you plug in for pi there?
Wait, what did you say?
The sheet should be on the right
180?
side too. Okay. Yes. 180 should go in for pi, and this should be divided by 6. So 6 goes into 180 how many times?
30.
30. Good. So 30 times -11 is?
What's I got it right here, Coach? Somebody said it -330.
Correct. And we know that. Here's an easy way. 3 times 11 is 33. Add a 0, get -330. That makes sense? So now if I have cotangent of -330, I can start at 0 and go backwards because I know that it's negative. All right? So how short do I come on quadrant 1 from the x-axis?
Let's have to subtract it.
Correct? You can.
30.
30, because we know 360 is there. We can just say that this right here is not -330. We can just say it's 30 degrees away from where I'm at. So now at this point, I know that it's a square root of 3 over 2, comma 1/2, right?
Are you gonna give us what cotangent is? Is it y over x or
It's. I'm not going to tell you. You need to know it's x over y.
x over y?
Correct. Okay. So if cotangent's x over y, what's the x in?
X over the first one.
Square root of 3 over 2 over what's y?
1 over 2.
Good. So if I flip this to the top,
By 2.
2 over 1, 2's cancel, giving me what's the answer?
Yeah.
Square root of 3. Yep.
You know the reference angle where you have to like draw it?
Mhm.
The reference angle is just like you have to subtract it from 360 to get it.
Yeah, let's make one up. Let's say I have 170 degrees, right? 170 would be here. I always ask the question, where's the closest x-axis? Left or right? Good, it's here. How far is it away? How far is it away from that x-axis? 10 degrees, exactly. So what's my reference angle?
180. Oh, okay.
10. So you always closest x-axis. So if you remember that, you're going to get every one of them right.
Wait, so like, for this one, draw the angle in standard position, it was like -150.
So where would that be? What quadrant number?
Third.
Good, yep. So we'd be down here, right?
Yeah.
So that's -150. What's the closest x-axis?
So what?
Good, and how far is it away?
30.
30, nice. 30 degrees.
Okay, I have a question.
Yeah, Morgan?
In order to make it, like to get it from 11 pi over 6 to 330, you have to multiply by 180.
180 goes in for pi to go from radian form to degree form.
Okay. And so the 170, that's the reference angle? Or
170 would be, where was I doing here? 170 is if I said, what is the reference angle of 170? So I graphed it in quadrant 2. How far is it away from the closest x-axis? Well, the closest one's to the left, and it's 10 degrees away.
Okay.
So remember, a reference angle has got to always be 90 degrees or less. It's never going to be more than 90 degrees. So let me give you one. What about 330? At 330 degrees, what would be the reference angle?
30.
Nice. At 270, what would be the reference angle? See, Katie. 270 would be where? Right here, right? That's 270. Where's the closest x-axis?
The one right behind it. Or no?
This one?
Can you not go back?
Here's a trick question. It's right on the line, so it could be either or.
Okay.
How far would it be away on either section?
Could it just be that? Like, I don't.
Okay, closest x-axis is to the left or to the right, correct?
Yeah.
It could be either.
Oh,
Why?
yeah. Because it's the same.
Perfect. Which would be what? Do you remember? Do you know? What's that distance there?
About 60.
It's not 60. What's one quadrant always? What distance? What angle measure?
90.
Nice. There you go. You see that?
Yeah.
So it's the closest x-axis. The only one that's confusing a little bit is that one right there, and you're good to go. You're welcome. Josh.
On the exam.
Yeah.
Show work.
I would. It's going to benefit you a lot because if you messed up, I have the opportunity to go back through and check those answers.
Is there gonna be enough room for it, or am I gonna do it on separate sheet?
There should be enough room for you. Should give you enough room, and I'll probably give you extra sheets if you need it. Okay. Perfect. I'll be right there. Any other questions?
What's the one your test numbers?
Great question. I really spread it out. I felt like a lot. Meaning like what I went through today is really good.
Like
Those
all the first one.
perfect. Yeah, if you understand the review sheet with some of the ones I went through today, it should be okay. All right. This is Coach Jay signing out. That doesn't mean those that are here, if you have questions, I still answer them. But this is Coach Jay signing out. We will be back here shortly for the pre-cal. Again, if you have any questions on that, please ask me. You can email me at any time, and I will go through those with you. Okay. Feel free also in the morning on Wednesday. Come on by. Other than that, hope you have a great day. We'll talk to you soon. Bye now.